I used to do that at like 4 a.m. Because I went to bed at like 9 o'clock last night. I was maybe I could actually have time to get up tomorrow. Like not.
I saw it.
What? You have to go.
So yeah, so I think from what I've recognized from the last couple of tests is we can do the calculus. It's just the algebra then that we're struggling with. Right. So are we okay up to here? Did we get
Wait, so you're just doing product rule?
Yes.
We're so stupid.
Yes.
Wait, what's what's your right answer?
The final correct answer is A.
Alright, we would have done it right if it was close, if we just said chain. Oh, you don't do chain rule?
So yeah, I mean we do have to do chain rule on this as well. Right? When we take the derivative of the square root of 4x minus 1, we had to use chain rule. Okay, so
I can't. I learn how to do this right now.
So, I mean, first I just rewrote it as x times 4x minus 1 to the 1/2 power. Then I used product rule, right? Derivative of the first times the second plus the first times the derivative of the second. So when I took the derivative of the second, I brought the 1/2 power down, didn't change the inside, subtracted 1 from the exponent, then times the derivative of the inside. So the derivative of 4x minus 1 is 4. And then in the next step, I just took the x times the 1/2 times the 4. 2x. You good up to there? So now we will have to add these together somehow to get one of our answers. Okay. To do that, we need common denominators. So at this stage, since our final answers are all in terms of radicals, it might be well, no, let's just write it like this. We'll leave the fractional powers in there for now. So plus, now, since this is a negative power, I'm going to go ahead and bring that to the denominator. So this is 4x minus 1 to the 1/2 power in the denominator. Okay? So now, how do I get common denominators to add these two things together? Yeah, so I'm going to take this fraction over here, right, and multiply both the numerator and denominator by this, right, so times 4x minus 1 to the 1/2 power over 4x minus 1 to the 1/2 power. Right, I'm allowed to do that because this whole thing is just equal to 1. So what happens then? What do I get when I do this? What's 4x minus 1 to the 1/2 times 4x minus 1 to the 1/2? Just 4x minus 1, right? So this then just becomes 4x minus 1 over 4x minus 1 to the 1/2 plus 2x over 4x minus 1 to the 1/2. And now I can just combine like terms in my numerator. Okay? Now I just get 6x minus 1 over 4x minus 1 to the 1/2. And the 1/2 power is the same thing as the square root. So we get A for our answer. Okay. We okay with that one? Well, I mean, you get, on the non-calculator part, it breaks down to 2 minutes per question. So, I mean, you get a little bit more time than you think.
Not much.
I mean, some of them though. I mean, we've looked at a lot where it's just graph interpretation. Like what's the limit? Like those kinds of things take you like 15 seconds. So there's some that will take 3-4 minutes. Some that'll take 15-20 seconds. All right. Questions? Good. All right. Questions on the cons. Those go pretty well.
Yeah. The second one, the advanced, whatever.
Third
Go on E, right?
The one with
I don't know. It was the second one. It was like
I know what you're
exponential advanced.
So we want to take a look at a couple of those.
the
The
one
E
I
ones
just
that you
looked
want
at
to figure out.
was
Once I start looking at examples, like I finally figured out how to do.
All right. Let's bring up. Evaluate.
I'm not sure if you're for you,
I don't forget. My time's gonna work. Good camera, but
I have to take it out.
I like it.
I'm not doing my best.
All right. So something like this: log base 25 of 1 over 20. Log base 25 of 1 over 125 equals what?
1/3.
So yeah, let's take a look at this. Right, we're trying to figure out 25 to what power equals 1 over 125. So the goal here is to break this down into something that can be raised. What's the best way to say that?
Oh,
Right. So what we need to do here is look for something that can be raised to a power to get both of these numbers.
So when I set up like that, like where is this equal to is like technically x.
Yeah. I mean, so we can think about it like this, right? We're trying to find some 25 to what power equals 1 over 125. So what we want to think about here is making this 5 squared equals like that. We want to break this down into the same base. Okay, we want to get both of these numbers with the same base. Right? 1 over 5 to the third is the same as 5 to the negative third, right? So what we end up with here is 5 to the 2x equals 5 to the negative third. So then 2x equals negative 3, right? Once I get these with the same base, I can just set the exponents equal to each other. Right.
I see when I got to these ones, I was like, Dinah, how do you do this? She goes, here, plug it into your calculator.
Yeah, well,
Not gonna lie.
like this.
Yeah, I don't know how to do it now.
Yeah, so on this advanced one, the goal was just to get these written with the same base. Right? So 25 is 5 squared, 125 is 5 cubed.
Can we go to the third one that was that E? Yeah. Like I looked at the hint or whatever, and it was like
The relationship one or the solving one? Solve one. Well, the solve one I think should have been the last one. I think this should have been the order they were in. I think evaluate advance, the relationship properties, and then solve. Like this. You're good on this?
This is the one? Okay. So we want to solve these exponential equations. First thing I have to do to solve something like this is get the exponential by itself. So I would divide both sides by 6. So I'll just rewrite that over here. So I'll have e to the 0.25t equals 9 over 6, which just reduced to 3 halves. Now, to get t by itself, what I want to do is take a log of both sides of the equation. Since this exponential is base e, I'm going to take log base e of both sides, which is natural log. Right? So if I do that, natural log of e to 0.25t equals natural log of 3 halves. So when I do that, log base e of e to the 0.25t is just 0.25t. Okay, the long explanation for that is we use our exponent rule for logs. I can write this then as 0.25t times the natural log of e. Well, what's the natural log of e? 1, right? That's why we take the log, the log base, whatever the base of the exponential is, because then we get this phenomenon to happen. So then we just get 0.25t equals the natural log of 3 halves. Then I can just divide both sides by 0.25 and I get my answer. Natural log of 3 halves over 0.25. Okay, so it says, put in that exact answer here and then put it into your calculator and get a decimal approximation. I didn't multiply, I took the natural log. So, because what I do to one side, I have to do to the other. Right, so I took the natural log of both sides of the equation. Okay with that? Do you want to do another one? Another one?
Alright, I guess I have to type all this in. What is that? Hogging them all. Does it say round to the nearest thousand? So 1.622. Oh, and by the way, we haven't really looked at many
Calculator questions on the AP or in the AP format, but you will always be asked to round to the third decimal place. Okay, round to the nearest thousand.
Alright, so
Let's take a look at this one. So here we've got 11 times 10 to the 5t equals 20. So again, I have to get the exponential by itself, so I'm going to divide both sides by 11. So I'll just get 10 to the 5t equals 20 over 11. Now I want to get my variable out of the exponent. To do that, we're going to take the log of both sides. Since the base of the exponential is 10, I'm going to take the log base 10 of both sides. So log base 10 of 10 to the 5t equals log base 10 of 20 over 11. So, again, the long explanation is the 5t comes out, log base 10 of 10 is 1, so I'll just write that as 5t equals log base 10 of 20 over 11, and just divide both sides by 5, and we get log base 10 of 20 over 11 over 5. Feel okay with those?
So, would you take a log base 10 and equal previously log base 10?
I'm taking log base 10 because 10 was the base. So we will take the log base, whatever the base of the exponential is. because then we get that property of log base x of x, right? That's the only way that that would equal 1. Feeling all right? Great. We're gonna do that in 30 seconds. If there are no other questions. So, no, any other questions on the cons?
All right, then let's get into derivatives of exponentials. So you have a guided note sheet that I made up yesterday. I've gone back and forth on guided note sheets. Where it is. Mostly because
You're not going to get guided note sheets in college, so
trying to kind of prepare
you to take your own notes to get in that habit. But the more I hear what other teachers do and the more success stories, it seems like guided notes work a lot better. And what do you guys think? Like, do you like guided notes? Yeah.
I do, but I also understand.
I like it for math.
I really
And that's the goal. So I'm trying to figure out what's the best approach to get you to that point. Well, and I think if we're going to go more in the direction of watching the lectures at home and then practicing in class, I'm probably going to give you more guided notes to help you follow the videos and that kind of thing. So, I mean, we're still going to do a guided note sheet today, even though we are going to have the lecture in class. So, this is actually section 4.4. I put 4.3 up there. Oops. We're skipping 4.3 and we'll come back to it later. So in this section, there's derivatives of exponentials and derivatives of logs. We're just going to do exponentials today, logs tomorrow. Right? So if I've got some exponential function, right? So this is like some number raised to some function. We're saying u is some function of x here. The derivative of that then is e to the u. Okay, just rewrite the entire exponential function times the derivative of the exponent. So u prime times the natural log of base. So I just rewrite the entire exponential times the derivative of the exponent times the natural log of the base. So just a couple of simple examples down here. Okay, for number one, if I'm following this pattern, the derivative of 4 to the x is just 4 to the x times the derivative of the exponent. So the derivative of x is just 1. That times the natural log of the base. So my base is 4 times natural log of 4. That's the whole thing.
So we can just leave it like that.
Yep, you can just leave it like that.
But you just write like 4x natural log of 4.
Mhm.
Will we ever be asked to simplify that?
I mean, there's not really any simplification we can do with this. I mean, natural log of 4 is just a number, and 4 to the x. I mean, you would on a multiple choice, you would probably just see it written as natural log of 4 times 4 to the x, because generally we put coefficients out front. Okay, but that's the only simplification that we can do there. Okay. So, how about on number 2? If I follow that pattern, what's my derivative for number 2 here? We should know what the derivative of sine of x is. Just cosine, Right, so 5 to the sine of x times cosine of x times the natural log of 5. So you guys go ahead and try 3 and 4 here. Alright. 3 did we get? 2 to the x squared plus 3x minus 1 times 2x plus 3 times the natural log of 2. And then 4, 3 to the secant of x times secant of x times tangent of x times the natural log of 3. Alright, sweet. Good so far?
Alright, so then let's take a look at a special case here.
E to the x. So we are still just going to follow our pattern, right? The derivative of any exponential function is the exponential function times the derivative of the exponent times the natural log of the base. So I'm going to write my function again times the derivative of the exponent. So what's the derivative of the exponent? 1. Right? Derivative of x is 1 times the natural log of the base. So times the natural log of e. Well, what's the natural log of e? 1. So the derivative of e to the x is e to the x times 1 times 1. The derivative of e to the x is e to the x. Is what always going to be? So the derivative of, if it's just x, that would be 1, right? But if we have 2x, that derivative is 2. Right?
So should it?
So this, I guess maybe I shouldn't have called this a special case. The only reason we're saying this is a special case is because the derivative of e to the x is itself. Right? We're still following that same pattern. Right? The derivative of an exponential is the exponential times the derivative of the exponent times the natural log of the base. So whenever the base is e, that natural log of e part, that part will always be 1 if the base is e. Right? But we always still have to take the derivative of the exponent, right? Because that can change based on whatever our function is in the exponent. Okay, so if we're following that pattern here, right, the derivative here would be e to the 2x times 2. Right? Technically, then we would have times the natural log of e, but we know that that's just equal to 1. Okay, so we don't have to write that. Yeah. So we could just rewrite this as 2 times e to the 2x.
We just take like the numbers in front of the x and put it in front of the e.
Only if this is a linear function, right? So I mean, for something like this, that would work. But yeah, if this is just a linear function, that would work. All right, so let's take a minute or two here and try 6, 7, and 8. used to.
Yeah, let's not do that. We have a goal here. We're almost there.
We're just a little bit over halfway.
Probably better.
Well, if we say 5 a day, we should be there. 5 a day. I mean, it's probably gonna happen.
Yes.
We're already at 3 today, and we have 17 or 16 left.
All right. So did we get these answers up here? Okay. The only kind of tricky thing that I threw in here was cosine of x squared. When we take its derivative, that's changeable, right? So the derivative of cosine is negative sine. So I would have negative sine of x squared times the derivative of x squared, so times 2x.
Okay, so I have a question. If the cosine was of x, then would you do product rule or would you say the change?
Wait, if this was cosine of just x?
No, if the cosine was x, like if it was like x.
Oh, x times x squared?
Yeah.
Well, there we could just make that x cubed. If
Okay.
that were the case.
Well,
But I see what you're saying. So like this isn't, we're not multiplying cosine times x squared. We're taking cosine of x squared, right? So yes, if this were like x plus 2 times x squared, then we would do product. We're multiplying two functions together. But here, this is just one function. This is just cosine of x squared. Any other questions on these? All right, then let's flip over and throw this into some product rule and quotient rule and that kind of fun stuff. All right, so on these, we're using our same ideas. Okay, we know the derivatives of exponentials now. We know the derivatives of trig functions. We know how to take derivatives of polynomials using chain rule, all that kind of stuff. I just threw some of these into quotient rule and product rule now. Okay, so let's take a few minutes here and try to work through these.
I just got really confused. I like freaked out because I saw like e to the x squared and I was like, how can e have 2 powers?
Let's do this.
Wait, so why are they, oh, because natural was
Right. Yep. It's the cotangent cube of fx. I mean, yeah. If we have to, whenever we have a trig function, we have to be taking it of something, right? So we can't just have cotangent cubed and then of nothing, right? It has to be of something. So even if there aren't parentheses there, we're taking cotangent cubed of 5x.
Oh, I see. Well, because like one time they asked me what else to do with all my stuff. I was not that.
All right. So how did we do on these?
They're pretty long.
They're long. Yeah.
On the right.
These were a little more challenging. But I mean, how did we do? Good. Field number 10. With subtraction, yeah. So square the denominator, bring the denominator straight up, times the derivative of the numerator, minus the derivative of the denominator, times the numerator. Any other questions on these before we take a look at the last two? Do what? Oh, okay. Can I erase? All right. So I wanna jump to 14 first, and then come back to 13. Make sure we do 14 here. Four minutes is plenty of time to get stuff done.
Wow, I'm so fast.
All right, so number 14 says at what point on the graph of y equals 2 to the x plus 3 is the tangent line parallel to y equals 3x plus 7? Yeah, what is this asking us to do here? Right. So what is the slope of this line? We have to what? I think somebody, Sharon, was that you?
No, I don't know that. She said you have to find the derivative.
I don't like that.
Find set
Okay, so
what
that
equals.
means to make the exponent of the first one equal to it. Or not equal to.
There we go.
Y. I know, but why? Okay, but it's like, oh, I understand.
Right, so we want to find our derivative here and set that equal to the slope of this line, which is 3. So, what's my derivative? 2 to the x times what? Right. You're trying to use power rule. That does not. We can't use power rule when our the derivative of the exponent. So it's,
does the 3 just cancel out then?
yeah. So then this is just a whole separate thing.
Right.
So the derivative of 3 is just 0. So now I want to set this equal to 3. Right? So I'm going to have 3 equals 2 to the x times the natural log of 2. Now I just want to solve this for x. How do I do that? Divide both sides by the natural log of 2. Not divide by x.
No, divide by 2. Log base 2.
Right? So, yeah. So this is what we did with those cons at the beginning today, right? Here we'll have to take the log base 2 of both sides of the equation. So when I do that, over here, this will be log base 2 of 3 over natural log of 2 equals x. Yeah, so then it says round your answer to the nearest 1,000. Okay, we would just plug that into the calculator then. And then it says at what point, so we would need the y value as well. So once I get that decimal approximation for x, I can plug that into my original function to get the y.
Do we have a math Excel?
There is a math Excel out.